Hello students, today we will be studying part B of motion in one dimension. Part B of motion in one dimension. It includes the graphical motion or graphical representation of whenever the object is moving in a straight line or in any manner, how we can represent in a graphical representation. Okay, first of all, why graphical representation is important, that we will be discussing. So let's proceed. In this chapter, we will be discussing three types of graph: displacement time graph, velocity time graph, and acceleration time graph. In all this graph, you will find that time is constant, whereas displacement, velocity, and acceleration is changing. Basically, we will see why distance time graph or why graphical representation is necessary. Imagine you are having a journey to certain location, and if you go on representing in terms of words, it would be quite boring. It would be very much boring. So if you represent the same thing in the form of graph, it will be quite interesting as well as revealing. You might have seen graph in case of cricket matches, in how much over, how much runs required, or what is the run rate required, or what is the run rate which has been maintained. All has been represented in the form of graphical representation. Why graphical representation? Because full matches overview or full journeys overview can be summarized in the form of graph. So first of all, we will be plotting distance against time graph. What it will tell us about the journey. Let us proceed. Whenever the graph comes, you should be knowing time is always taken, no matter whatever the graph is. Time has always been taken on the x-axis. This is the x-axis. Graph consists of two axes. One is x-axis, another one is y-axis. Okay. Time is always taken in x-axis only, and distance is taken in case of y-axis. Why time is taken in x-axis? Because time, we consider time as constant, or else you can tell we will note down the distance traveled after equal amount of time. Take for example, after 1 second we will be noting down, after another 1 second, after another 1 second. So time will remain constant. What is the term changing? That is distance. Whichever term will be changing, that will be taking along y-axis. This is what been said. Direction denotes that it is moving from origin to distance goes on increasing, and time is measured in seconds. It is going on increasing. Time is taken on x-axis and distance is taken on y-axis. Now imagine you are sitting at particular distance from the kitchen. Okay. As the time is going on increasing, whether the distance between you and your kitchen is increasing? No. Why? Because you are sitting at a single place. As you are sitting at a single place, so distance is stationary. Distance is stationary, or else you can tell that you are a stationary object. You can tell you are a stationary object. Stationary object means what? As the time is going on increasing, this arrow is denoting it is increasing. As the time is going on increasing, the distance with respect to the origin, this is the origin, the distance with respect to the origin is remaining constant. This distance is remaining constant, so we say that this object is stationary. This is another graph. As the time is going on increasing, distance from the origin is said to be constant, so the body is said to be stationary with respect to time. As the time is going on increasing, body is stationary or body is not moving. Next one, body is moving with uniform velocity. What do you mean by uniform? Uniform means what? Constant velocity. As displacement, it is increasing by same amount in each second. You can see this is the time axis or x-axis, it is denoting time, and this is the y-axis or position axis or distance axis. You will see that after 1 second, distance or the position traveled is 10 meter, another 1 second, another 10 meter, it is going on and on. Okay, so you can see that it is traveling equal distance in equal interval of time. from 0 to 1 second it is traveling 10 meter, and then again from 1 meter again it is again traveling 10 meter, again 1 meter, 10 1 second 10 meter, again 1 second 10 meter. So what is this this type of motion is called uniform velocity. Over here we can find out what is called as velocity. We are knowing that velocity's formula is what? Velocity is displacement upon time, or distance upon time. Velocity is distance upon time. So distance or position is one and the same. Distance or position is one and the same, and time, this is a time axis. So by substituting over here we can get velocity as well. How we will be getting that, you will be able to understand in the next slide. First of all, we will be choosing any 2 points. We have to choose any 2 points, but that 2 points should be lying on this line only. That should lie on this line only. It shouldn't happen that you are choosing this point and this point, then your graph is wrong. First of all, you have to plot a graph, then you have to choose any 2 points. I have chosen this point A and B. I have chosen this point A and B. Okay. Over here, B's coordinate can be given as what? x2, y2. Why do we say x2, y2? Because this is a higher coordinate. Whereas point A can be denoted as x1, y1. Okay. We will be finding the velocity with the help of the slope. The slope's formula is what? y2 minus y1 upon x2 minus x1. y2 minus y1 upon x2 minus x1. You might have done this in maths. If you have not done, then try to understand this. Over here, see, this is what I've said. This is denoted by x2, y2, and this is denoted by what? x1, y1. So what is the coordinate x2, y2? Just 1 minute. What is the coordinate over here? x2. What is the coordinate over here? x2, 4. What is the y coordinate of this one? You have to find the x coordinate of B and y coordinate of B. Okay. X coordinate of B is what? 4. So I am writing over here 4. It is denoting x coordinate. What is the y coordinate of B? It is 40. So I will be writing over here 40. Similarly, what is the x coordinate of A? That is 2. And what is y coordinate of A? That is 20. Now I will be substituting this over here. What is this formula? y2 minus y1 upon x2 minus x1. What is y2 over here? y2 is what? 40. So we have written over here 40. What is y1? 20. So we have written over here 20. What is x2? x2 is what? 4. 4 I have written. What is what is x1? That is 2. So 4 minus 2. So we will be getting the answer as 10 meter per second. Okay. It is not that I have got the velocity only if I choose these 2 points. If you choose any point, even if you choose this point and this point, or this point on this point, you will be getting the same answer, because the velocity is uniform. Okay. Or this object is moving with constant velocity. If something is moving at a steady speed, steady means what? Uniform speed. It means we expect the same increase in distance in a given time. Like we have already seen, for each second, for each 1 second, the distance was travelled as 10 meter. It was increasing. Time is increasing in the right, and distance is increasing steadily. Time is increasing in the right, and distance is increasing. Distance is increasing, but it is increasing at a steady pace. It is increasing at a steady pace from this origin. With respect to this origin, as we are moving over here, distance is increasing. Are you able to understand? As we are moving from year to year, distance is changing. This graph shows an object that moves at a steady and constant speed. Over here, 2 lines are there, yellow line as well as blue line. You can see one line is steeper or near to distance axis, whereas one line is not steeper. Can you tell me in which line the velocity is more? This line velocity will be more. We will find it out. The steeper slope indicates larger distance. This line is steeper. As this line is steeper, so it is indicating that it is traveling more distance in very small interval of time. Are you able to understand? Within this small amount of fraction of time, it is traveling so much of distance. If you compare this by this, it is not traveling that much amount of distance. Okay. If we substitute the values, you will see that yellow line is speed is equals to distance upon time. What is the distance traveled from year to year? Distance traveled is 30. Distance traveled is 30 and the time span is 10. Time span is 10 seconds. Whereas in case of blue line, what is the distance traveled over here? Distance traveled is 20 and time span is also 20 seconds. So 20 upon 20, 1 meter per second. So you will see that yellow line is having more speed, that is 3 meter per second. So over here speed is more. This is one more graph. Whenever the distance time graph is showing the slope in this manner, it shows that it is a steeper over time, or it is traveling more distance in very short interval of time. It is traveling more distance in very short interval of time. This is also called as accelerated motion. Take for example, vehicle is at rest. We accelerate the vehicle. As soon as we accelerate, the graph will be at like this manner whenever we are accelerating. In other words, in a given time, the distance the object has moved is larger. It is an accelerating motion. Like I have already said, it is called as accelerating motion. Over here, three types of graph has been given. This blue, this navy blue, I think so. This is sky blue and this is pink. Three types of graph has been given. You will find that over here, 3 stages has been given. It is traveling in the first stage. It is traveling 100 meters in 10 seconds. For next, it is traveling 50 meter from year to year. We will be considering from year to year what is the distance traveled? 50 meter. 50 meter in another 10 seconds. And from year to year, it is again traveling 150 meter, but the time span is what? Now 20. So time span is 20. You have to calculate the speed for each section. So what we will be doing? Speed is equals to distance upon time. What is the distance traveled over here? 100 upon 10, that is 10 meter per second. Similarly, stage 2, it is about 50. 50 meter is traveling, and for traveling 50 meter it is taking 10 seconds. So it is 50 upon 10, 5 meter per second. For stage 3, it is 150 and the time span is 20. So it is 150 upon 20, that is 7.5 meter per second. Okay. So in stage 1, stage 2, stage 3, there are 3 stages which you should be knowing. Stage 1 is traveling with constant speed. It is traveling with constant speed and at a relatively high rate. You will see that it is traveling with constant speed, but the speed is more. So therefore, relatively high. You will see that in stage 2, it is slightly inclined. Means it is traveling with constant speed, but it is relatively slower. In third stage, you will see that it is moving towards the origin. Means speed is decreasing. Okay, speed is decreasing. So constant speed at a medium rate. It is traveling with constant speed at a medium rate as it is traveling towards the origin. The slope of the line indicates the rate of change of position. Indicates what? Rate of change of position. Speed can also be estimated with the help of the slope. Like we have said that this line is moving faster as compared to this line. Okay, so this also prediction can be done with the help of this type of graph. In run rate also, you might have seen like this graph. Over there also prediction is given by the commentators. That from, take for example, from 0 over to 10th over, they have scored more runs. From 10 to 20, the pace, there was a lot of wickets falling down, so the pace was slower. Okay, like this commentary has also been done, if you have heard. Next one, stage 1 and stage 3, you will see that it is moving away from the origin. It is moving away from the origin or away from the starting point. In stage 3, you will see that object is moving back to the starting point. Object is moving back to the starting point, means it is coming to the steeper the line on a distance versus time graph, the faster is the object speed. Steeper the line means what? Take for example, this is a graph, steeper line. Steeper line means what? Whenever it is towards y-axis, it is called as a steeper. Means what? This line is moving more faster as compared to this line. The curved line indicates that the change there is change in speed, so it is accelerating or de-accelerating. Whenever the graph is of a curved nature, it is like this curve, it is what showing it is accelerating, and if it is reverse manner, then it is showing it is de-accelerating. Okay, de-accelerating means what? It is negative of acceleration. Okay, line pointing up indicates that it is moving away from the starting point. If the line is pointing up, means what? It is moving away from the starting point. This is velocity time graph which we are discussing. If the line is pointing down, then it is showing what? It is moving back to the starting point. It is moving back to the starting point. Now we will be starting with velocity time graph. In velocity time graph, we will be seeing velocity is distance upon time. Velocity is distance upon time. With the help of this, you will see in this graph basically time is again in the x-axis as well. Why time is in the x-axis? Because it is not changing, or we will be taking the time after certain interval. Like over here, they are taking the time after each 5 seconds. You will see the velocity is remaining constant, that is 4 meter per second. Okay, so over here we can, with the help of velocity time graph, we can find out distance traveled. Velocity is distance upon time. If we take time over here, then what we can write? Distance is equals to velocity into time. Over here we just have to consider this shaded region. What is this shaded region? This is a rectangle. So area of this shaded region is what? Length into breadth. What is length over here? 15. And what is breadth over here? 4. So 15 4 is what? 60. Body will not be accelerating. Why it is not accelerating? Because acceleration is what? Change in velocity. Acceleration is what? Change in velocity with respect to time. But over here velocity is not changing, or velocity is constant. So acceleration will not be taking place, or the velocity is said to be constant, so it is said to be uniform velocity. Object is moving with uniform velocity. Next one, you will see that this graph is moving away from the starting point. As it is moving away from the starting point, so over here velocity, it is called as a uniform acceleration. What is it called? Uniform acceleration. And you will see that we can again find the distance traveled with the help of area of a shaded region. What is this shaded region denoting? This is denoting a triangle. So area of a triangle is what? Half into base into height. So what is base over here? 15. What is height over here? 6. So half into 15 into 6, you will be getting the answer as 45 meter. We can also find acceleration as well with the help of this graph. Acceleration is formula. Acceleration. What is acceleration? Change in velocity upon time. Acceleration is what? Change in velocity upon time. Over here you will see that y-axis is denoting velocity and x-axis is denoting time axis. Okay, so all this term can be denoted in y-axis and all this term can be denoted in time axis. So likewise, so slope we will be using, slope is y2 minus y1 upon x2 minus x1. Over here y coordinate which we will be taking, what is y coordinate over here? Y coordinate is 6. What is x coordinate over here? 0. So it is 6 minus 0. Again we have to consider this x coordinate. What is x coordinate at this point? X coordinate means what? We have to consider this one, that is 15. 15. And what is x coordinate at this point origin? That is 0. So it is 6 minus 0 upon 15 minus 0. So you will be getting the answer as 0.4 meter per second square. This what we have got, that it was moving away from the origin. As it was moving away from the origin, so over here acceleration was there. Now this is one more graph where acceleration is not there but opposite of acceleration is there. Means it is retardation. Okay. So again we can find out the distance traveled by considering this area of a shaded region. This is a shaded region, this is in the form of a triangle. So area of a triangle which we will be taking half into base into height. What is base over here? 15. What is height over here? 4. So half into 15 into 4, you will be getting the answer as 30 meter. Next type of graph which will be starting as acceleration time graph. Acceleration, like acceleration is not a constant term, so it will be taken along y-axis, whereas time is a constant term, so we will be taking time again along x-axis. But whenever the object is moving with uniform velocity, or whenever the velocity is kept constant, acceleration is not there, so acceleration is said to be 0. Acceleration is said to be 0, and acceleration time graph is a straight line coinciding with the time axis. Acceleration time graph is a straight line, means acceleration will be 0 because there is no change in velocity. What is acceleration? Change in velocity upon time. But if velocity is only not changing, so acceleration will be equal to 0. As acceleration is equal to 0, so we will be drawing a straight line that will be coinciding with the time axis. Now we can see that object is moving with constant acceleration. If the velocity of the body is moving in motion increases with uniform velocity, velocity is increasing in a uniform time, so acceleration is constant. It is an accelerated motion, but over here velocity is moving, velocity is changing, or velocity is increasing. So therefore this type of motion is called as accelerated motion. In such a graph, the acceleration time graph is a straight line. Acceleration time graph is a straight line, and you will see that it is parallel to x-axis. It is parallel to x-axis means what? Take for example, over here 5 is there, 5 meter per second square, means body is moving with 5 meter per second square only. Okay. Next one, acceleration time graph, but over here you will see that retardation is happening. Retardation means what? It is moving or brakes has been applied. As brakes has been applied, so you can see this retardation happening at a negative x-axis, negative y-axis, sorry. It is happening at a negative y-axis. If the velocity of the body changes in an irregular manner, the acceleration is variable. The acceleration time graph will then be a curve of any shape. If the acceleration is happening at this manner, then it will be curved of any shape. It can be curved of any shape. So this is a main thing which you should be knowing. Out of this 9 diagrams, any diagram can be given, and they might ask you the type of motion which is denoting. This is a stationary object. Whenever the object is stationary, and if we want to find out displacement time graph, x is denoting displacement, v is denoting velocity, and a is denoting acceleration. In case of displacement time graph, if the object is stationary, then we will be drawing it in this manner. Velocity time graph, object is again stationary. As the object is stationary, velocity is 0, so we will be drawing this graph which will be coinciding with the time axis. Again, if the object is stationary, acceleration will be also 0, so again this line will also coincide with the x-axis. If the object is moving with uniform velocity, distance time graph, uniform velocity, so it will be like this. If the object is moving with constant velocity, as the velocity is constant, so this graph will be like this. Again, velocity is constant, so it is not accelerated motion. A is equals to 0, so it will be coinciding with the time axis. Now when the motion is moving or the object is moving with constant acceleration, as it is moving with constant acceleration, so we will be getting like this graph. It will be a curved nature. Curved nature means what? There is some sort of acceleration happening. So velocity time graph, we will be drawing it in this manner. Velocity time graph will be directly proportional, means velocity axis is directly proportional to time axis. Velocity is changing at a constant rate. As velocity is changing, so therefore acceleration will be also there. Acceleration will be there, so we can draw it in this manner, which will be parallel to x-axis. Thank you.